So this sort of innovative course was brought as a first course in our session, in our IFL optometric tutelage. And we have got 20 students from Vinayaka Mission, for those 20 students, Vinayaka Mission has completely sponsored for those students. And we have also got a sponsor for 7 of our students from Viscent as well as from V Square Meditech. Here today, we have Ms. Maheshwari to show us what our VR based VR kit will be, how it will look like, how this device, technical device will look like. So she will be showing us how it will be, and she will be giving us one short video also regarding the course and testimonials what we have got from our students, post which we will move on to the session. Can you show us the kit, ma'am?
Yeah, sure. Can you please stop share, Ramesh? So can I share now? Or?
You're going to show a video or a physical kit, ma'am?
Yeah, so the sharing of the students, I will be sharing now.
Okay, fine.
Should I do that?
Yeah. You can share the review.
Yeah.
Yes, testimonial.
So this is the sharing of the course.
Hello there, I'm C. Subhashri Lakshmi, a third-year optometry student from MN College of Optometry, Chennai. As far as we all know,
video is
an
not
optometrist is someone who works either in an optical shop or...
1 second. My video, 1 second. Sorry. Is it coming now?
Hello there.
Yes.
I'm C. Subhashri Lakshmi, a third-year optometry student from MN College of Optometry, Chennai.
Yes.
As far as we all know, an optometrist is someone who works either in an optical shop or the one who do refraction in a clinic or an hospital sector. But IFL Optometry made us to realize that optometry is a vast field. In fact, I'm one among the many students who have enrolled in their virtual reality in optometry course. Through that course, we all came to know the various perspectives and the new advancements that are happening in this optometry field. Thank you, iFull Optometry, for polishing us in a way that we all gonna create a very new revolutions in this field by creating our own instruments that will be used by many future optometrists out there like us. Thank you.
Hi, I'm Vishwas, and I'm a PhD student here at MIT Manipal, and also I'm one of the enrolled student in the course of VR in optometry, which is conducted by iFull Optometric Tutelage. Well, regarding the course VR in optometry, I chose this course because this is going to be very helpful for me in knowing the basics of optometry and how to design a VR instrument to measure visual function assessments, which is closely related to my PhD topic. So I thought of learning some of the basic concepts when it comes to optometry and VR. So that's what first 3 classes were related to the optometric side, which they covered regarding the lenses and how the lenses can be useful in creating a sharp image in VR. Well, I was very helpful with all these information that has been provided in the initial part of the course, and I'm looking forward to gain more information which would help in my PhD work, which is completely related to the optometric side and also the VR side as well. So thank you.
Hi, first of all I thank to Ms. Savita ma'am and Ms. Maheshwari ma'am. I got wonderful opportunity to learn virtual reality. Before joining this course, are used for gaming purpose. After joining, I learned how to create virtual reality devices that can be used in optometry and ophthalmology field and the scope of optometrist beyond the regular refraction. Once again, I thank to virtual reality team.
Hello all, good evening. Myself Dhanlakshmi. I have completed optometry in 2014. Recently I came across virtual reality in optometry course. I was excited and interested in knowing new things. Till now we have gone through how to construct a virtual reality box, which is really very advanced. Happy to be part of the session. Thank you so much for this wonderful opportunity, Maheshwari ma'am and Savita ma'am. Thank you.
So thank you so much for sharing your experiences, participants. So now I will be showing what we will be giving you for the experiments. So as a part of the course, we have been teaching so how to decide your object distance and the image distance and the focal length and all that. So accordingly, how do you adjust your magnifications? How do you test this? So this is an experimental device. So this is custom made. So I sat with our engineers. So thanks to our engineering teams for designing this. It's a very simple. We are making it at a very cost effective price. So so the advantage of this system is, hope you can see this system. I'm bringing it as close as possible. So it is, you can see that it is adjustable in the length. Okay, so you can adjust your object distance. Okay, so the u value that we were calculating, so you can adjust the distance. Okay, so the another thing is, you have a place to insert your mobile and then you can keep it back inside. So another wonderful thing is, in no VR headset, you have this option. You have this. It's just a opening. Okay, so you can insert any lens. Okay, so so it's a variable focal length, a variable object distance, and accordingly your v value or image distance also changes. Okay, so this is as far as I know, this should be the first experimental virtual reality headset. So you can play around. You can play around with the different u values, v values, and the f values, keeping different lenses, and try this. So that will be a very good thing for a beginner for doing the experiments. So so we have made it, we want to make it as cost effective as possible. So we are like, it is around 1,500 rupees. You can just if anybody else apart from the course also, if you want to try it and for any other experiments, we would like to help the researchers for their experimental purpose. So so thanks for this opportunity. I would call Savita to continue the introduction with Dr. Ramesh.
Thanks, ma'am. Ma'am had actually worked behind this VR set with engineers, and it was a difficult thing actually to catch hold of them. They were really busy, and we wanted to finish this course also on time. We wanted to do the projects also on time. So and also, like, everyone came with their own ideas, and the U value changed. So make an instrument with the which can incorporate different U values. We thought of something which can be used for the same instrument. This same instrument can be used for different purposes. So that is the whole advantage of this experimental VR device. I really thank Maheshwari ma'am for bringing this whole device to the industry. Thanks a lot, ma'am. And over to today's session, I have to thank Dr. Ramesh first. Dr. Ramesh, if I have to, he doesn't need any introduction. We all know him. Dr. Ramesh he began his career as an optometrist and a clinical researcher in 2001, and has academic, clinical, and research experience in the field of optometry. He's a professor currently in the Department of Optometry, Mahe. He completed his doctorate in PhD in 2014 from BITS Pilani, and he was a part of epidemiological study, Chennai glaucoma study, and Chennai eye disease incidence study conducted at Shankar Netralaya. He is also one of the India coordinator for Erasmus project, RAMUS project, Optometry Curriculum for Life, Long Learning through Erasmus Oculus. Oculus is a consortium of optometry educators with the aim of reform optometry education in Israel and India towards European standards. And he also has keen interest towards techno entrepreneurship, and he actively supports and is the founding director of Viscent Healthcare Private Limited, incubated at Manipal University Technology and Business Incubator, and recipient of Biotechnology Ignition Grant. Dr. Ramesh has 70 research articles in peer-reviewed indexed journals with H index of 22 and has filed 4 patents. And he is currently listed among top 200 optometry and vision science researchers globally, and he's one of the 2 researchers listed from India. The list goes on and on and on. So I need another 1 hour to introduce and to tell his accolades, and he's like, when I was a student, I was like looking upon him thinking, okay, I should be so knowledgeable like him. So over to you, Dr. Ramesh.
Thank you.
Stage is all yours now.
Thank you, Savita. Thank you, Maheshwari, and good evening to all of you on a Sunday evening. We're all meeting, and thanks for the good introduction. And it's all dedication to my gurus and all of you who are motivated in every part of journey. And it's always a lifelong learning, especially when your interest is in making public health devices, public health related eye care technologies that can reach the masses. I see virtual reality is, or the virtual augmented, the metaverse environment is one of the most promising areas, and it is very important that all of us are lifelong learners, and that is what you guys from Optometry Tutelage, along with the whole community, are doing. Congratulations to all. I hope my screen is visible. So this
Yes.
presentation is part of supported by my colleague Dr. Kritika and Ms. Dorotha from the Ramesh team. Okay. So basically, Viscent Healthcare is a startup that which helps translate some of our research activities at the Department of Optometry at Manipal into tele and home eye care technology. So we have a core research team on gamification of vision, where one of our PhD scholars whom you saw, Mr. Vishwas, was also there. So we work on developing new technologies, collaborating with partners across the globe so that we can provide technologies that will connect patients and clinicians and provide continuous monitoring that is there. And today I'm going to talk about virtual reality-based therapy that we have been working with Ramesh since 2018. And this was supported and connected through an Erasmus grant that was mentioned in my introduction. And we have been working in this product development, and in India, we are happy to be launching it this year. And we hope to scale it up in the near future. Okay. So the problem statement, when all of you are going to work in developing new technologies, it is very important you understand what is that key problem solution that you are creating, right? So we started with looking when our colleagues from Remed, they were expertise in gaming and VR. And as you know that today in 2022, after metaverse introduction, the market is expected to grow at 18%. Okay, cumulative annual growth rate of AR VR industry. Okay, by 2028, we are expected to, it's going to be around an 80 billion or even more market space. So when you're looking at gaming, is not mostly VR and technologies were used in healthcare education, right? Or mainly in gaming and in education aspects. Okay, how we can provide you anatomy, physiology training, or help you understand, or let a patient understand where the visual problems are. But we found that, okay, we saw a unique opportunity wherein the pain problem was towards a disease known as amblyopia. As all of you are in the eye care domain, you would know that, of the children who are 2 billion children population who are studying globally, we see a prevalence of amblyopia, which is lazy eye, between 1 to 5.3%. Looking at that prevalence rates published in India, we see a 7 million kids in India are having amblyopia, right? So we looked at what are the key training problems. And before I talk about how we genesis this idea and what are all the solutions that went on in this product development as part of the coursework, and also talk about the features that we provide as part of the BV, amblyopia solution is also provided. So let us understand amblyopia first for the students who have joined today. So amblyopia is a main reduction of visual acuity for which there is no structural organic cause that could be found, so mainly we say two-line differences, but that is changing a lot. Okay, mainly that is added to over the years, various supplementary criteria have been added, not just vision. Subnormal visual acuity is one, and very rarely even both the eyes can have low vision, poor vision, but that vision loss cannot be related or correlated with any other disease the patient has, right? So another amblyogenic risk factor present during visual maturation, that these children are identified only during pediatric school screening. I think just before we started this session, I was really commending the good efforts from OATN and others on connecting with the Tamil Nadu government on creating more early school screening, right, to find out amblyopia or myopia. When we do that, we will be able to find amblyogenic risk factors, children with amblyopia much earlier. Okay, so there are a lot of intraocular differences in visual acuity when you have unilateral amblyopia, and along with visual acuity losses, it is well reported that the child has difficulties in contrast sensitivity perception, the child has difficulty in stereopsis, there is vergence-related problems. So all these together combines and leads to a poor quality of life for the child. So the child might have reading challenges because of the inherent amblyopic conditions, and they will, very on a lighter note, they will never be able to enjoy a 3D movie well, as all of us with both the eyes with good fusional ranges do. All these are a problem. And amblyopia is highly treatable, and age is not a criteria that has been very well noted. And I will touch upon some of the literatures that talk about even in adult amblyopes, how we could bring back and reduce the risk of amblyogenic risk factors and bring back the quality of life for these patients. Okay, so if you look at it, the most common types of amblyopia could be anisometropic. But we'll start with strabismic amblyopia. Strabismic amblyopia, basically there is a ocular misalignment, mostly uniocular. So each eye does not have the same image on the fovea. That's a simple way to understand, right? So there is a deviation. One eye is either EXO, EXO, or if there is a traumatic thing, there may be more of a cyclo or a hyper and hypo deviation. Okay, so but the most common type of amblyopia is the anisometropic amblyopia, wherein there is a difference in refractive error. So one of the foveal image is more blurred than the other. Therefore, during the visual maturation, so from the time the child is born, the quality of the information that goes from the more blur image or the weaker eye is neglected by the visual processing. Therefore, they develop amblyopic risk factors, and they tend to be not appreciated. Third one is there is stimulus deprivation, including ametropia, so large symmetric refractive errors. Amblyopia is residual visual deficit after physical obstruction is removed, right? So this is not a direct developmental thing, but it could be because of cataract that was there in the congenital cataract or ptosis or some other refractive conditions, which after treatment, the child's visual system is slowly adapting. So this is the most common classification of amblyopia, right? So as we all know that amblyopia is highly treatable, okay? The critical period is considered as something between birth to 6 months, okay? If we can diagnose the amblyopic risk factor, which is very challenging because we do know that there are not much standard tools that could very critically give us the visual function assessment in these children, okay? But there is also some of the congenital diseases end up with legal blindness in nystagmus. But most of the amblyopia treatment starts in the second column here. There is a sensitive period wherein we look at okay, somewhere between 6 months to 8 years. But even in the Western or most of the Indian things, we have seen patients somewhere around the 4-year age group. That is, so when they join the preschool, they're not reading well, and that's when they're detected with some eye vision problem, right? So the upper age of age limit for onset of amblyopia was earlier considered as so from 6 months onwards, there is a higher risk. But if we see, these are the very important point, right? If diagnosed at that age group sensitive period, an aggressive treatment is provided to the visual system, then there is an improvement in the visual functions. Okay, and the lack of treatment results in visual impairment that could be permanent altogether and takes more effort from the child on a later on period during the susceptible or the residual period when they have to undergo therapy. So susceptible period is considered between 8 years to 18 years. Okay, even here, these are the classical cutoff, which is what we were taught way back in 1997 or 1998, is something like 8 years and above amblyopia you can't treat. But that is not true. We see that even if the child is during the schooling time as per the Indian education system, if we can treat them very well, aggressive treatment for amblyopia is preferred, there is a very good possibility to reduce the amblyogenic risk factors, improvement in visual acuity in other aspects that I talked about, right? So mere patching is not enough. Patching only improves visual acuity, but how about going to develop the other functional aspects that they have lost during the developmental period, like the stereopsis or fusional aspects and even contrast perceptions or ability to appreciate the difference in contrast and things like that. So we need to be more aggressive during the susceptible period. And the biggest challenge here is if there is an inherent amblyopic amblyogenic risk factor still present, say there is a microsquint that is there, or if there is suppression is not monitored properly, say for example, if there is not a good refractive correction that is provided, and though treatment is provided only by patching, it will improve, but you're not treated the whole visual system. So what happens is after the patching is removed, you will see that even at this age group, the patients again, because the reading requirement or the education requirement increases, the eye again, the good eye starts to take over and say, okay, fine, now I have to perform academically well. I'm not in a mood to only treat you. So mere patching is not enough. So we need to look at what are all the amblyogenic risk factors that are there in the child and then provide a more comprehensive treatment. And the later one is the adult amblyop group, which is the residual plasticity. Okay, the prognosis is minimal. So, but if the personnel, the he or she who is adult amblyop is highly motivated and is able to simulate those parts of the visual neural system, then we can see that amblyopia does not recur even, and there is improvement in visual acuity and other functions also, right? That is what most of the research and also our experience is showing. Okay, so what has been the pain point as we now understood what is amblyopia? I just gave a small introduction to amblyopia and then how the treatment aspects go. And I've been very periodically saying eye patch is not enough. This is the most medieval method of treatment wherein we put the eye patch, and the moment the patch is there, it is like if you're a right-handed person tying your right hand and asking you to do your homework in left hand, right? So the child is not so happy, right? They try to cheat a lot. The moment the mom or the parent moves away, they remove the patch, and getting them to wear the patch is one of a more difficult task for the parent, right? But that is the most easiest thing from a clinical point of view. If you see most of the pediatric practices, you see amblyopia, even if they have vergence related problems or some amount of the fusional aspects are not really, suppression is not well documented, they end up saying, okay, just patch and let them watch TV. What happens is when you do that, they are not engaged in activities in the amblyopic eye. Because when you look at a visual display unit, if you're watching patching and asking the child to watch a movie, there are other simulations, right? There is a more wider screen that is there, okay, illuminated screen, But what is the other cue? Audio cue is what is the child is going to be more using rather than the visual cue. There are some researchers that are now being done both at Mahe and also globally to look at whether simple non-activity of passive exposure to just patching and letting the weak eye use for activity of daily living, is it useful? Okay, but the way we should understand, the physiology improves better or the therapy shows better results if we give activity to the amblyopic eye, and that is well known in all our clinical experience. That's what we do when we call the patient to our office, right? We this is the age-old method of using synaptophores for virgin solator and simultaneous macular perceptions, or pleoptics was earlier done, but that is highly debatable from research point of view. But we do a lot of tranaglyphs and other interactive Dicaptic simulation activities. But these are monologue in the sense like it's the same activity the child has to do. Okay, and the biggest problem what happens in a clinic is when you are sitting with amblyopia child therapy, you cannot move away from the child, right? So the parent has problem bringing them 2 to 3 times a week, and most of the therapies, depending on the amblyopia amblyogenic risk factors the child is suffering from, ranges from 6 to 24 months, right? So looking at a long period of follow-up, and there is poor compliance over time, right? Similarly with eye patching, compliance is very poor. And this is where the pain point that we felt, virtual reality, okay, with the quality dissociation that it can do, shows one image to the right eye, one image to one video, or one subset of data to the left eye, is a fantastic tool to provide a comprehensive amblyopia treatment, not just patching, but also going to all levels of amblyopia, right? So in looking at various methods, we have the optical correction, that is the most important, right? When you see an amblyopic child, do a fantastic refraction, ensure that you are providing them the best corrected visual acuity. Patching, yes, it is very important, but you should also club it with binocular therapies. And that is what the recent clinical trials, both open and closed label clinical trials, are showing us today. So in our case, we start looking at perceptual learning, binocular virtual reality therapy, and Dicaptic training as binocular vision therapy. So we wanted to combine both patching and binocular vision therapy together and inspire from what pharmacological therapies are doing. So if you want to give an atropine that basically creates a blur in the good eye, so we also wanted to simulate that kind of an feature into the VR therapy system, so that you can introduce certain filters that mimic blur, that mimic contrast. Say if you want to put in neutral-density filters, and that's what your school of thought or you believe has shown success, then we have those kind of features that we have enabled in the virtual reality system. That is what we're going to show. So this is a collaboration that has been there, a company from Ramesh, which is based in Poland, and Viscent and Ramesh have been working for the last 4 years together in both co-creating new products, validating it, and also launching it in India. Viscent is a key partner, and we call it BV, right? Moment I was happy to see that, because in India we have our BVs who always say what is right. Right? We in Hindi, it's wife, so wife is always right. So we felt BV is the right solution for amblyopia therapy, where patching is not just enough, right? So what do we provide as a technology provider? Is we use one of the Pico is now being bought by a group known as TikTok. Most of you might know what is TikTok. So TikTok company is the owner of this hardware, but we have arrangement with them wherein this is the first virtual reality headset that has been approved for health application, and we have a CE and US 510K approval, and the Drug Control General India regulatory approvals are in process now. So we provide a dedicated virtual reality goggle with eye tracking. That is one of our key features that we bring in. So you will be able to visualize the eye movements of the patient. And then we provide a complete, touchscreen control unit and complete gamified vision therapy for children. Okay, so there are three components. We have the goggle, a microcomputer, touchscreen computer that can help you, you as a clinician input all the detail, and games that are the software that run for the child with amblyopia to be treated for at various levels of amblyopia. So BV system has used well-known methodologies in traditional vision therapy. Okay, and we have taken the best of the scientific evidence and incorporated into a virtual reality experience, which you as a clinician can control it through our cloud system, so that the doctor can train the child in the clinic and then provide even home therapy very effectively. And our research has shown very consistent efficacy and earlier better results in as compared to traditional patching therapy. So the therapy using things is a functionally given game-based therapies are provided. Okay, so we have tools that provide therapy for all grades of binocular vision, binocular single vision therapy for amblyopia. So we start with occlusion to monocular simulation, binocular visual field, dicaptic simulations, then to fusional aspects and stereopsis and vergence related therapies. For saccades and pursuits, we have games that have ensured eye movement and eye tracing, kind of eye-hand coordination exercises, and also for vergence related problems. So these are the clinical applications that we can work on, right? So if you look at it, from 2015, this is one of our ESO alumni, Indu Vedamurthy, who have been working in this area with Dennis Levy and team, wherein they looked at, okay, what is the basic dicaptic thing? So the dicaptic simulations came with normal video games, which was Tetris. All of us have played this game. The biggest challenge is the game is quite boring after some time, right? So the basic idea is to dissociate the game so that one eye sees certain cubes, with the other eye they have to map. So the pattern or the orientation of this bricks will be shown in the left eye, which could be the amblyopic eye, and they would have to use the data from the right eye, which is the good eye, and kind of map it. So basically, you should see that this is a kind of a perceptual learning that happens. Okay, so since this publication or this work from even the PD's group and other publications showed that Tetris game was a good introduction, but it was quite boring. So they got more immersive games. So the good eye sees no targets, but the game have activities only in the amblyopic eye. Therefore, this kind of simulation is a dicaptic-based simulation that have been highly appreciated, right? So the key characteristics for any dicaptic game should be that there should be a split screen, so independent control of games with the left and the right eye, and that's where if you compare the whole gamut or the spectrum of hardwares available in the thing, VR is a fantastic application because augmented reality or mixed or next level of interactive realities that are going to come have a different application. But for this problem statement of amblyopia, virtual reality headsets are fantastic. And then the perceptual strength of the image, that is what I want to present in the good, that is the strong, and which is otherwise called the bully eye, and the weak eye, whether I can improve the illumination in the weak eye so that they see better in that eye. So information that goes to the brain from the weak eye should be able to be both from the good and the weak eye should be adjustable, right? And there should be a very engaging progression of difficulty during the game level. And we have also taken an extra effort to ensure that none of our games we have engaged with educational psychologists, educational experts, and parents and teachers, all stakeholders in the product development, so that none of our games will have a more virulent thing. We don't do a PUBG kind of a game where in a clinic you have to say, hey, kill the monster. That's not the instruction that you can give. So most of our games are highly child-friendly, and those are very important. And the fourth one is also an important characteristic of any dicaptic game, that is binocular alignment has to be facilitated and suppression checks should be there during the part of the whole mechanism. So that is what we do in the product development journey. So whatever are the best methodologies prescribed and the research outcomes that have come from various research across the globe. Our product development has taken all those into considerations and developed a whole series of games. Okay, so today we have developed about 10 games based interactions. Okay, if you see the A, B, C, D, that is A, which is known as the underwater treasure, B, which is a fish, wherein it's eye-hand coordination, and C, which is a snowball game where they can use their head-mounted tracking also, and D, these are all have amblyopia therapies at various levels, starting from monocular, that is occlusion, then slowly reducing the dependency on any of the filters or reducing the use of both the eyes together, that is biocular, and then going on to binocular, where you can fuse effectively and bring in dicaptic and anti-suppression training in all these games. And the examples as shown in here on E and F. E is on vergence, wherein we look at how you can train on your convergence and divergence related problem. And F is our stereopsis training module, wherein we would be able to look at which is trained at various disparities, both at near and far stereopsis. So the sequence of vision therapy for strabismus, if you say monocular, that is the first effect, equalize the visual skills between the eyes. So we first start with improving the visual acuity, that is monocular, and then gradually ensure that by reducing the effect of patching, by reducing the filters or putting new filters into the good eye, therefore slowly we are equalizing the visual skills. Both the eyes are equally valued by the visual system, and there is activity, and you will see that the fusion or flat fusion start with flat fusion with suppression checks and also provide feedback mechanisms are there, and we eventually move on to vergence therapies and fusional exercises in our games. Okay, so researchers have critically shown that dicaptic training is very useful both in the sensitive period and critical period, and researchers on older adult amblyopia have shown that if you have a dicaptic simulation game that has better potential offered by VR for perceptual training of all kinds, and other anaglyph as compared to anaglyph based method, VR based games have better outcome in providing a comprehensive improvement in the visual function of the amblyopia child. Okay, so game-based virtual reality therapy on adult amblyopes has shown improvements in visual acuity, stereopsis, and dicaptic training using virtual reality on adults has shown improvement in not just visual acuity and also the other stereoscopic and other functions that are very important for a amblyopic child, right? So with this, I think we can either choose to take a break now. I will leave it to Savita to decide on that. Okay. So if you think we need a 5-minute break, we could just break here. And after this, I will walk you through our device, the settings and the key features in our things, and then end up with one clinical case and talk about our business model strategies, both in India and globally. Okay, so Savita, do you want a break now, or would it be okay for me to continue?
Yeah, we can break here, and we can join. Please do not leave the meeting. Be in the meeting only. Just you can join after 5 minutes exactly.
Yeah, I've just played a video so that in case. Hope the video is shown here.
Yes.
Yeah, so it's going to talk about both there's no audio in it, so don't worry.
Okay.
Because I was supposed to give audio back, but it's only a visual display.
Okay. Thank you. So we'll join back exactly after 5 minutes.
At 6:30? Yeah, now it's 6:20. 5 minutes. What's your?
Yes, 6:25.
Yeah, that's no problem.
Thank you.
We cannot hear the audio, Ramesh. Okay.
Hey, sorry. No, there's no audio in it now.
I understand. I understand.
Yeah,
Because of the
yeah.
queue,
So,
queue cut. You have cut the queue.
yeah.
Okay.
So let them have a break from my audio thing also. Again, if they listen to the same tone of voice and things,
So I'm seeing Jemima here. Hi, Jemima. Welcome. Thanks for
Hi,
joining.
Maheshwari.
Hey, hi, Jemima. How are you?
Hi, yeah, fine. How are you?
Fantastic, fantastic.
Thanks for joining, Jemima.
Welcome, welcome. Some of the students also have joined. I have asked them to join.
Okay.
So, great. Nice to have you, Ramesh. And thanks
Thank
for
you,
the
Jemima.
initiative by Maheshwari and Savita.
Welcome, yeah. So I'm seeing, is there any other?
Thanks a lot. Thanks a lot, ma'am.
People in the group? I'm just seeing, is there anyone?
I didn't hear you, Maheshwari.
Yeah, I'm just checking. Is there any other known people in the
Okay,
group?
okay.
So I'm
Yeah,
just,
Ashwini is there. Ashwini is also.
Yeah, Ashwini I saw.
Okay.
Welcome,
Gopinath
Ashwini.
is there.
Oh, Gopi is there.
Thank you. Thank you.
Yeah, I think Gopi ends up hearing this lecture quite often.
Okay.
Yeah. And then his thesis is shaping very well, and he would soon be doing his defense. Good luck to you, Gopi.
Okay, so yeah.
Good
Even
luck.
I'm
Congrats.
at college, yeah. Hi, ma'am.
Congrats,
How are you?
Gopi. Hi.
Gopi is also from Manipal, right?
Yeah, ma'am.
Yes.
I did my post graduation here and hoping to defend my thesis in a couple of months. Yeah.
Oh, great.
PhD.
Congrats.
Thank you.
So Gopi is doing PhD under me and Dr. Rajiv Raman sir from SN.
Okay.
Oh.
That's great.
And he gets a lot of support from Dr. Shonraj also. So and Dr. Hari here. So that's another good talk series. That's on age-related macular degeneration and how we can look at understanding the application of their visual problems and looking at how we can detect earlier with newer perimetric approaches. So perimetric, and he has also done evoked potentials, that is more of an EEG related study as part of his PhD work. So again, a multidisciplinary work where we have engaged with speech learning pathology specialists and ophthalmology colleagues as always.
Super.
And I think as we wait, yeah. So one aspect you can see that we are the environment of core research is growing significantly in our country, and recently my classmate and our good friend Dr. Jay Kishan and Dr. Richa, they are optometry partners, colleagues who are part of human brain computational brain research at IIT Madras, and they have initiated their center there. So these are very big achievements in the field of thinking like how optometrists can be engaged in core science research areas also. Right?
Yes.
And in our country, it's really a moment of pride. So good. Okay, Savita, I think she gave a nudge saying that okay, let's start up. Yep.
Yes.
So let me continue with the talk. So just to give, this is okay. The person you're seeing is Dr. Shonraj. He's the current head of the department at Optometry. So this is our device at Manipal. So again, it is BV system is very useful for binocular vision disorders, for office and home treatment. Okay, so the key advantages, as in the earlier the talk I was talking about the pain points, right? So when a patient is at office, initially after they get trained in vision therapy and the system is working well, then while the patient is doing therapy for half an hour, you can see another patient. So thereby permitting you to do more patients. And since there is a more engaged and foolproof vision therapy systems, home treatments are more robust. Even the parents do not need to be sitting with the child doing the therapy, but the child is always fun engaging in doing this therapy. So we see virtual reality thing as a crowd puller in our Amblyopia clinic, wherein even compliance puller, not just crowd puller. The child is interested to come for vision therapy. That is the first achievement. Second, he is now listening to patching advices without any tantrums, or with less tantrums rather. So, which means that, the things we say very jovially, you want your VR therapy this month, then this week, then you need to do your patching properly. So it's an augmenting thing. You simulate those neurons which are not being active for since the childhood, and now how we can improve it is the key functionality that we do. So by simulating those regions, we are letting them, by major control dicaptic conditions, we are improving their visual facilitation, and therefore we can provide both anti-suppression, fusion, and Virgin's therapy. Okay. So the system can be used for all grades of amblyopia. Strabismic amblyopia, we have a fantastic feature where we can introduce virtual prisms into the VR system. That is, we create a virtual environment for the degree of prisms. We have non-strabismic binocular vision disorders and eye movement disorders. Okay, accommodation things with the current technology, we do not have facilities to train them, but but it also includes more of perceptual learning, and the whole engagement with the child provides stimulus that can train on accommodation. That is, we have control mechanisms that help them train. So this is the components of VR. So you have a touchscreen input computer which connects. We need an internet connectivity that will enable the communication wirelessly between your VR headset. The one device that you're seeing here is one of the most advanced VR tools, known as the Pico Neo Eye. So as I told, I think you can appreciate the eye tracking, right? So we provide real-time eye tracking data, right? You'll be able to visualize where the child. This is a patient who's using their glasses. So even with the glasses, we can look at how their eyes are aligned, and we'll know where the foveal fixation is happening. And I've demonstrated a cyberpatching, that is complete patching during the therapy. So these are game-based amblyopia therapies. So the list of therapies that you're seeing here are here. These are the various IP on these things. So how we have designed and developed these games has been told already. But most of these games have features for dicaptic and complete amblyopia anti-suppression therapy from end to end. And a few therapies have a fusional and stereoscopic stereopsis level therapies too. So basically, we provide key features known as general filters. These are the controls that we provide. So when you're developing your own device technology, you should also look at how is the end user going to interact with the virtual reality system. Okay, and a quick example of how we show patching. This is a cyber patching, we call it, where 100% patching is done, and then we also provide reduction of that level of darkness or the illumination control that is there. So cyber patching provides no cheating that is there. Okay, it gives a monocular gameplay, but we also provide differential filters, which are blur, contrast, and you can reduce the contrast. So you know that by this, we know that if this is the left eye and the right eye of the patient. So left eye is the dominant eye, so we have patched it. And after patching therapy, as the visual acuity of the amblyopic eye improves with the combined patching therapy at his home, the child's we slowly reduce the dependency of that differentiating filters like blur and things. Therefore, eventually they can come to this level known as the MFBF, monocular simulation in binocular visual field, which is on the eye, which is amblyopic. We provide all the activity, but the good eye is also exposed, right? It's having the same background, right? So these are some of the examples that we have shown. Okay, and then after you improve the visual functions, when the visual system is also able to appreciate the input that is coming from the amblyopic eye, we would go about even control settings. These are some settings that we can enable how the aiming controller can be and things like that. So these are anti-suppression control settings, basically looking at fusional training. Okay, so the input can be alternatively given to the left and the right eye. It can swap, and even dicaptic therapy, which means that For example, if the number of, I'll show you one example of dicaptic. So here is dicaptic therapy. So now the data from the both the eyes have visual improvement has happened. So now there is the suppression in both photoarteries is gone, but you want to improve the fusional ability, then we provide a dicaptic simulation wherein if you see the activity, that is the gems, 3 are in one eye and 1 in the other. So now, and they have to fuse the information from both the eye to win the whole level of this game. So this is one aspect of dicaptic level gaming. The one advanced feature that we have gotten is also on contrast, wherein how do we train these children on contrast perceptions and things. So gamified versions of transparency of the targets that they are supposed to play can also enhance their ability to see at different illumination levels. And we also provide for the, and there is something known as a virtual prism, which is for patients with squint. Say, I've simulated a condition where it's very crude. Nobody has such bad squint kind of a thing in amblyopic congenital, developmental amblyopia. But, we have created virtual prisms that can be used to ensure that the alignment of the visual system is there. Okay, so these are some of the key features, and then I'm sorry that I'm skipping these slides quite quick because I initially expected this has to be a course. So for the coursework, I thought I'll extend, but now this is opened related to the IP and other things. So I had to, I'm just quickly moving on to the next slides. Fine. So we can provide a lot of vergence and convergence related therapies at various distances. You can choose the distance you want to provide the therapy. And you can do convergence and divergence level fusional therapies, right? So this is things, and you can, by varying the size of the object, you can simulate a little more of accommodative targets too. Similarly, the last one is on stereopsis training. So it comes on with how we can look at various disparities from 3,600 arc seconds to 40 arc seconds, and how you can ensure that the child is trained on the stereopsis. So now I would quickly walk you through one of the cases. Okay, so this was a 9-year-old male. As you can see, this is a classic anisometropic amblyopia, with the right eye being the amblyopic eye and the left eye being the dominant eye. Okay, he had no established squint, so except for a 4 prism exophoria for near. There was a suppression for distance and light suppression for the near. Stereopsis, he could see the fly and could be around 400 arc seconds to start with. So for this patients, we looked at amblyopia, the BV virtual reality therapy, 8-step game therapy, both at home. So we prescribed this technology to the home, and the child will play 2 sessions every day for 20 minutes, so for 30 minutes every day, and being intermittently followed up. And this was part of an ongoing case series study, clinical trial that we were engaged in, right? So what we wanted to achieve was equalize the visual skills. So improve the monocular acuity first, and then go on with biocular therapy, where we would want suppression check and improve, ensure that the amblyopic eye is getting actively engaged in the whole visual perception activity, and then go on with fusional exercises with binocular convergence and cognitive flexibility therapies, right? So we, maximum, our recommendation for this patient was about 50 minutes. So I said 30 minutes per day, which means 5 minutes of break. 25 minutes is maximum that we give. So it's around 20 to 50 minutes per day in 2 to 3 cycles. Okay, home-based therapy should be started at effective therapy settings are verified in your office, which means that you have to train the patient very well on the game and the exposure, what he is expecting very well, and parents should be informed, and parents can monitor what the child is seeing through our app. So it is very easy that they will be able to see what the child is doing. So we loan the headset, control, and tablet, which needs to be charged. We have to train a little more. So patient education is slightly higher, but the childs are more game savvy. So the moment you explain to them, they just give them the controller, they start to play. Okay, the first thing we started was 20 days, 20 minutes twice daily is on cyberpatching, that is e-occlusion. Okay, so we started occluding the left eye, which is the dominant eye in this patient, right? So after this causes complete scene blackout in front of the left eye. So we are making the child use the amblyopic eye. And after such 20 days of therapy, we were seeing that there is an improvement in visual acuity that started to happen. So the follow-up happened after 20 days. And the next 20 days was anti-suppression therapy. So we started introducing some filters, use darkened, blurred, or reduced contrast scenes. Okay. So we provided no activity on the good eye, but introduced some filters. Okay. Something like the darkening. We introduced some amount of darkening. Okay. People also introduce blur if they look at, blur from pharmacological thing, the child is quite habituated with that, then we would provide even a blur. So by introducing these things for the next 20 days, and since it is a cloud-based system, you can remotely engage and change your settings. So the child's gaming performance is improving. Then after 15 days, you could gradually reduce this from 60 to 0, right? So that is the aim. So the aim is to bring them to anti-suppression level 2 therapy, that is on monocular fixation, binocular visual field level, where by even though the good eye is seeing everything clear, but the brain is actively engaged in appreciating the amblyopic eye activity. So this means that the suppression has been overcome, right? So we can introduce these kind of filters, right? And all these things are gradually monitored and modified, and the selection or the level of how much of filter to be given is highly individualistic. So you have to do it in your clinic, okay, and see what the patient is able to do better, and then control it during their home visit too. And you can see that between these two pictures, the amblyopic eye image has been slightly enhanced. So we can also increase the brightness levels of the amblyopic eyes. Therefore, they could see much better, right? So this was a 20-day session where they introduced this kind of blur, and then they were able to appreciate and improve the activity. After this, so this is a 40-day therapy for wherein we were able to achieve visual acuity improvement and also break the suppression chain that is there, and there was anti-suppression checkpoints that we have provided. Followed with this is where we started with MFBF, that is monocular fixation binocular field. Okay, that is anti-suppression therapy 2 level, wherein we looked at, okay, the good eye is seeing the same background, but all the activity is there only in the amblyopic eye. And our filters that are there in your control panel will help facilitate all these activities. Okay, the parent would not be able to touch any one of these, and you as a clinician can prescribe and modify at your own convenience, even not required to call the patient for a review. Okay, if the patient's gaming is improving, he's able to hit everything properly, and for 3 days he has done, then our online report will show you that, and then you can make these modifications and have a telephonic conversation or a teleconsultation with the patient saying that I made some modification in the game, in the therapy to the parent, but the child will see it as a new level in the game. That's all. He's going to have fun with it, right? So then after 15 days, after this 40 anti-suppression level 2 exercises, also included some aspects of simultaneous perception. That is wherein we show that the aiming is now that, for 5 days, they were able to play only with the good eye, seeing only the background, but then we start providing some inputs. The good eye will also now be actively engaged. So you will focus using the information from the good eye, but look at and play using the amblyopic eye to finish the level of the game. Okay, so this is simultaneous perception. Okay, and then we continued with alternative things. So for fusional aspects, you can see that here the targets are getting alternated. So with every click, you will see that at one time the target to be achieved will be on in front of the amblyopic eye. After the next click, it will be in front of the good eye. So thereby we can improve their fusional aspects. A small target display alternatively will help control central suppression and improve their fusional aspects gradually. Okay, and at the end of this exercise, so it took us somewhere around 40 plus 15, 55 and 75 days of continuous thing, we were able to see from the baseline, which was 20 by 70, the visual acuity improved 20/20. Okay, that was just by around 130 days, we were able to see a classic improvement in their visual acuity and no change in their their ocular alignment. But what was good was follow so no suppression, and stereopsis improved from 400 arc seconds to 80 arc seconds. So this is what, and then the good thing that we are seeing is in our recent case series, we have seen that the number of patients who have been on only patching, okay, since that the inherent amblyogenic risk factors are not being corrected, okay, so moment the patching is stopped, there is again there is amblyopia setting in, that is the visual acuity dropping down in patching cases. But in as compared to our patients who are using patching plus BV, the rates are significantly lower, and that is a very promising thing that we are slowly publishing soon. Okay, so to give you a summary of what all you can do, how we help you in the clinical thing is, if you're looking at key visual acuity in one eye, that is the monocular improvement, we can either conventionally we do patching, pharmacological treatment, optical treatment by providing over plus or bring in some filters. But here we can easily do it with Cyberpatch and differential filters. Okay, and suppression we use monocular fixation, binocular visual field by using anaglyphs and dicaptic activities, right? But here we can easily provide with a very engaged game-based exposure that you can see, and dissociating prisms, synaptophore, and stereoscopic examinations. All these which you can do in a clinic can now be done on the virtual reality world, right? Similarly, when you're going to look at fusional and Vergence training, we have a whole set of Vergence and even virtual prism that will help you stable increase in the Vergence ranges and also in fusion, right? So we are looking at improving. We have a facility wherein we have good games that can improve eye-hand coordination, to provide better pursuit and circuit training in additional. Some of the research works that are getting and are being currently reviewed and things, and we are soon starting our clinical trial, randomized control trial in this year. Okay, so now the last part of today's session, which will more be like helping you understand on how the system works. So basically, Remed and Viscent is the India commercial partner. Along with Remed, we will train the eye care specialist. Okay, so the key of the therapy to select in VR is not a magic pill or a magic device. Nothing is, right? So the key is we are providing a very engaging and intuitive environment for the child to child or adult amblyope, where his visual systems can be simulated much more effectively. But the clinical diagnosis is the key. So if you are a pediatric ophthalmologist or a pediatric vision therapist person, it's very easy for you to get trained with our system. And along with your conventional practice, then you would recommend your vision therapist to be using it along with your optometrist or ophthalmology colleagues who will be prescribing it to the patients, right? So our two market strategy is through vision therapy clinics and ophthalmology hospitals. We wanted to experiment a different model, that is mainly used as, product as a service are known for, cataract, phaco machines or say LASIK instruments where companies will give. But even for these smaller instruments, we have a business model where can I request Shinmoy to please mute, because sorry, I'm unable to focus on them.
Kapil, can you mute everyone? Chinmoy, please.
Hey, thanks. Sorry, because no offense to anybody there, it happens to all. Okay, so basically what we do is, we have a credit-based systems wherein a clinic can basically engage with a minimum of 100 to 100, 500, and 1,000 credits, and these are all timeline dependent, right? So it's like your prepaid credits that you have for a prepaid card. So each credit is somewhere around 300. Each credit is for a 30-minute session for a patient. Okay, which again. Yep. Sorry, need some help. Sorry, guys.
Yes.
Yep. Sorry for doing that quite often. I know it might annoy all of you. So we have a charges wherein it's as less as 300 rupees is the cost that we have come out with. So wherein plus GST will be there. So per session, per patient, our charges that a clinic would need to pay us is 300. So a minimum of 30,000 would be good enough, and this 100 credits will be valid for 30 days, kind of a thing. So within a month, if you're able to see so many so many patients, you can use these 100 credits, and the clinic can add their cost, okay, for such an high advanced tool and care, and then and also earn for the next recharge, kind of a thing. So we earn with you. That's the model that we bring in, and this is the clinic model. And then if you're looking at home therapy, so after you train your patient, and if you want that patient to take up a 3-month therapy, okay, so per month the patient will end up paying around the Bata rate, kind of a thing, 9999 plus tax to us. So you add your administrative cost to it as a clinic, and then you can prescribe it. And then what we do from Viscent is we from the say this is the hospital or your clinic, and then you prescribe. Then we very potentially we send from Viscent, we will be able to connect with the patient and provide them with the headsets. And this feature we are going to start only by end of this year or mid of this year, because we are looking at adopting to a most cost-effective hardware tool so that we can reduce the cost from 9,000. But currently we are live on business. We should be live on business with the office therapy tool. Okay, that is what we have installed at Manipal now, and also at Eye Foundation is currently using it on a trial for some time. And we hope we would have a few more clinical things with in this near future, right? So basically what happens is, moment the child is doing all these things, so the clinic does not need to take care of who will send the instrument and all those things. Logistics that are there, that is taken care by our company. And then moment the child is doing the therapy, our technical support team will also help them to ensure their setting ups are all right. And then moment they finish the therapy, without sharing data with us, the doctor who has prescribed will be able to monitor what is happening and assess progress effectively. Okay, so the first thing is diagnosis and treatment planning, creating a patient account, and as a clinician you should adjust what games and what level of amblyopia therapy you want. And then you say, okay, I want to, you suggest for home therapy, and then we would provide the instrument, okay, and all what you are prescribed. So this is something like the game settings will not be used. It's like a highly controlled prescription. So one of the questions most commonly asked by parents are, isn't it going to harm my child? You know, since our therapies are only 25 minutes per day, so 25 to maximum of 50 minutes a day on 2 different sessions. So you prescribe it. So I want to do only 2 sessions or 3 sessions for the child. So morning and evening, 25 minutes, and the system will only operate that respective time. Other times will be locked in. They cannot be using it for other gaming purpose. So this is a very important factor that will ensure safety and efficacy. Okay, and that is why we are into a model wherein we are looking at hardware also to be loaned to a patient, so that we can't say, for example, the kind of model that the experimental design what Maheshwari ma'am showed. It is very easy to adapt to that. You know, it is no problem. It is very cost effective for a company to do it. But the biggest problem for us is if the screen is scratched. Okay, that will impair the visual problem. So from an ethical or a safe efficacious treatment, we have to provide, as an industry partner, we have to provide an efficacious, safe and provide technology that is going to augment your visual engagement. So that is why we're not going with Google Card or any of those options at the current juncture. Right. So this is our things, and some of the research work that is currently ongoing at Mahe and is on glaucoma, where Dr. Shonraj is the key PI, and I'm a co-investigator in the thing. So, and we have a research scholar, Ms. Priyanka, who's working on applying mobile eye tracking technology for early detection of glaucoma. Okay, so and then we have got a seed fund from our incubator, and also we are in the final stages of Elevate 2021, wherein we are looking at integrating VR with haptic gloves for upper limb rehabilitation. So we are looking at how we can enhance the chronic stroke rehabilitation also. So this is a completely interdisciplinary project that is on, wherein we work with the head of physiotherapy at Manipal, and also the head of neurology at Kasturba Hospital here. So we have a center for stroke rehabilitation where we connect, and we are developing this product together with them. And we also already a couple of IPs on aspects of, we have started working on newborn screening, and AI models are things that we are going to integrate and make it more automated. But currently, all the current VR systems are highly controllable by the end user. Okay, so the key value propositions that we bring in is, these are kid-focused methods to improve binocular vision, right? And all levels of therapy are provided, and the selection of these headsets are quite high-end because it needs to have at least a 6 degree of freedom. I think in the session, Maheshwari ma'am would have talked about the degree of freedom that is there, like how the VR environment needs that 3-dimensional appreciation and a 4K exposure, so that there's no lag that is happening during these gaming therapies. That's why we needed quite an advanced tool. And since we wanted to also provide then eye tracking, that's why we went on to Pico, and Pico have been very well supporting our journey so far. Okay, so our solution is based on immersive gaming experience, and it provides a highly clinician-centered adjustability for therapy process, and which can be monitored remotely, making it a tele rehabilitation tool. Okay, so thank you, one and all. I think that would end my session today. And thanks for the good opportunity, and we are happy to have supported the Optometry tutelage team. Yeah.
Thanks, Dr. Ramesh. That was an extensive talk, and it is quite interesting also. Dicaptics has been well established in BV, and I feel I myself now interested in bringing this into my clinic also. I usually give clinical therapies when it comes to amblyopia. So home-based therapies are actually, for us in COVID times especially, it is difficult for every parent to bring the child to the clinic. And it is also nowadays every home parent, both of the parents are working, right? Like it will be an added advantage for them if we can have something like this at their home, so that the child will be treated also. So this is such a wonderful innovation which you have brought in, and I think our students would have learned so much today that what an VR system can do to the society. Like when you have said, like when it comes to VR, you can incorporate many things because the split screen option is available.
Agreed.
Right? So you can block one eye in a V way. If you want, you can increase the contrast, decrease the contrast. If you want, you can add some filters. Everything is like whatever you want, that is possible with VR. So if you are a good clinician, you can be a good innovator also, because you know what to do.
Agreed. So that's where our core innovation has been. This the data that I've shared is highly, we have around 8 intellectual properties patents around this, and the whole team on all these activities that we have done. So even more, they're now publishing more IPs globally too. So when you're starting with any problem statement, it is very important to engage with
Please
with the key.
Priyanka, can you please mute Priyanka?
Yeah. So you need to engage with the key stakeholders, understand the problem statement. See the current outcome or the current intent of the course is to interest you and enable you or to sensitize you towards such an opportunity. But the product development journey has a huge responsibility because you need to ensure that you have understood the pain problem and there is a need in the market and we can provide a cost-effective solution till the end. That whole lifeline realization is very, very important, and that is highly possible today because the ecosystem across India is fabulous. With Atmanirbhar concepts and recently I saw the Maheshwari's team, wherein the the minister from Tamil Nadu has met them, and they were all interested because there is so many funding opportunities available. But what we need to look in is not just do a small project. Start with the small project, but when you're thinking big, you need to really understand the whole business model and how we have to really bring in an effective solution. That is one thing that is very important.
Yeah, Dr. Ramesh, it was a very interesting thing. So I've seen one question from the chat box. Mr. Bhagavat is asking, like, he wants to talk to his ophthalmologist. So can you please guide him how, because he's asking for the PPT, maybe you will give a different version of the PPT or
So I can send a basic promotional thing to them, and since we are a small team, we have yet to scale up more nationally. We are just growing and raising some funds all together. So by this year, I think we should be more mature to launch it and scale up well. So we need all the good wishes and support. So I'll be happy to share some details by sometime next week. Yeah.
Mr. Bhagavat, can you please give your mail ID or contact to Ms. Savita so that we will coordinate and get the things done for you? Or if you want to ask anything particular, you can.
Yeah, Ramesh, Dr. Ramesh email ID is also mentioned here. You can directly also mail him, or you can contact me also. Like I can, put you across him so that you can work together. Like whatever we can be doing in favor.
Yeah, he sent his mail ID.
Yes,
so
fine.
We'll do the needful. Yeah.
And as Dr. Ramesh has mentioned, there are so many things to do. Like, see this particular. How many patents, Ramesh, for this? Around?
So the Remit team has totally around 18 IPs around it, and core on these, because on the key aspects of 8 IPs and 4 on the programming and everything. So the intellectual properties are a good way to ensure that investors are quite strong to come to you, because they're going to see that you have a safety thing. So even today I presented it today. Okay, I'm confident that we have that ability to defend in the market. That is where you should look at. IPs are basically a very good way that you should enhance. If you're a core researcher, then you can go with open source. But when you are developing products and services, and when you want to raise funds so that you can ensure that your idea is taken globally, intellectual property is a very good way to ensure that you and your team have the strength to be able to develop this journey.
And also here, I also want to mention that in pipeline, we also have one course where we guide you how, if you are having a big dream towards bringing on project, or you want to bring in something different, innovative in the business, we are here to guide you on how to get patent. So that course is on, in our pipeline now. So we'll be announcing it very soon. So you can
That's
make
very
use
good.
of it. We'll guide you how to get patent and how to proceed with, funding and stuff. So stay tuned to Eiffel Optometric tutelage. And I think any questions further? I think there are 3 more chats.
Yeah, if anyone has any questions, you can unmute yourself and ask also. So in the meantime, I'll be asking some of the questions which are coming to my mind. I was just wondering how we will charge this device. So is it like when the patient is using it, we cannot charge it, right?
Yeah, so between patient visits, you would be required to charge. So with the eye tracker thing, the charging is the key thing. It's basically an Android system that is there in most of the commercial VR systems, right? So you have a port that you can use a C-type charger and charge both the headset and also the remote that controls it, the pinch controller.
So these clinical outcomes you have explained, it was very, very interesting. In 130 days, you got this. What was the, you may be seeing, very interesting to see the child's reaction. Normally, children must be liking it because it's game. So how the parents are reacting and how they are supporting for this?
That's a very nice question. So from a child point of view, recently, there was one child who had a stimulus deprivation amblyopia, but 1 unit of cataract, and she had around 2 meters only on visual function assessment. Because, but in a VR environment, when we put in, the child started to play the game very well. We thought that she would not be able to see even that, and slowly the vision is now improving to 6/60. 6/36 is what I'm expecting by the next 10 days. So what is happening? The child is more happier on because our whole therapy is providing not just on vision alone, but eye movement strategies. We have not studied on the educational impact of these kind of therapies, but I think that is one thing that should be done, wherein we can look at how the educational performance can also be affected. So from the parents' point of view,
okay, your voice is breaking.
It helps them a lot. And India, is it better now?
Yeah, better.
So so in home therapy we have very limited exposures in India, but from our experience in Poland and Europe and also in US, we are seeing that home therapy, not just COVID, it helps enhance compliance, right? The child is doing exercises daily, and the parents their time is highly safe. So but in our case, our main challenge was the pricing and things like that, because currently if I end up charging you 10 to 11,000 per month for home therapy, that's quite an expensive thing, because we have to charge it because the hardware, we take the risk on the capital. So if the child breaks the hardware, we have to cover on that and things like that, right? So that's why we are trying to move to different platforms. For example, if a home therapy can be done on the most commonly available commercial tool in India is the Oculus. The Oculus Rift is one of the hardwares from the Facebook family. Many of us have used, and there is almost 1/3 of the price of the competitive thing that we are using, right? So thereby can reduce the cost. So, but these are something that our team is working on. That is why I have not launched we have not launched the home therapy significantly, but I am really thrilled with the work that our team has done on the eye tracker aspect, because we'll be having a real-time eye movement data also using the Pico Neo eye that we are using.
So this eye tracking is already done, or it's in the experimental stage?
So it's already there. Like, we have already implemented the eye tracker. So we will.
Yeah, we have seen during the presentation.
I forgot. Yeah. So you will, while the game is performing, you will have real-time eye movement where the child is looking. So if there is more of eye movement and tracing, then you can instruct the child. But when there is a squint and things, and when you are trying to create a virtual alignment prisms and things, you will know where the alignments are and things like that. That's the advantage of an eye tracker.
Yes.
Yeah. So this is offered by this hardware.
Okay.
The hardware is provided by the TikTok group, that is Pico is the manufacturer. So again, all made in China again, so
it's looking very nice. Just so curious to know what is the weight of the device. Yeah.
See, the initial versions of Pico, which has been their fourth generation, Pico Neo 3 is coming now in India. So Pico started with the one, they were around 750 grams. And this one is just about 520 to 570 grams. And they have a counterbalance weighting thing, which is their IP, nothing to do with any of our Remed or anything. This is the companies, the hardware companies, IP is on this whole thing, wherein they have a fantastic thing. They have a 4K resolution. Okay, they have 6 degrees of freedom and 110 degree of visual field thing. So this is and the optics, the kind of the frontal prism optics that has been used is so beautiful that you will never have fatigue even after 45 minutes of engagement with in the VR environment. So children at the age of 4 have been using it. So the youngest has been a 3.5-4-year-old child who's doing therapy with us, and it's no problem for half an hour. So we are trying to we also done a couple of things with stroke rehab patients, but we don't. The VR thing might not be very good. This headset, any of these headsets, can be good for a patient with developmental things, say with CP or where they don't have a trunk stability and things. It becomes challenging.
Yeah, so looking very nice, and it would be very interesting, when you expand to different parts of our country. So it will be very interesting. And I'm seeing some of the chat messages. So they are all saying thanks for the good session.
Yeah. I really wanted to thank Ramesh for not only this enlightening session, but also for sponsoring 5 of our students. He had really, the moment I asked him whether he would be interested, he said yes. I really wanted to thank him for that. And also,
Pleasure.
the session was really interesting. It was like, I think these students would have thought, okay, fine, we can do so many things with VR. The whole point of this VR courses make them think out of the box. Okay, you can do something better. You can do some innovations, creative things. So that is the whole point behind we bringing the VR session. And
agree, Savita. And another very important point, Savita, is like see the work that we're doing with stroke rehab and things, wherein the next thing that we from our profession, these technology can connect with disciplines that are not across disciplines.
Exactly.
So, for example, today in India we have a lot of wearable devices. I've started working with one team known as Holo Suit. They are in Mysore, but likewise there are in IIT Chennai. Across India, there are so many manufacturers who have gloves, whole body suits that are there. So what is going to happen is when we have a patient with the risk of falls, or when we want to develop their strategies to say mobility and home adjustments, training a low vision patient for their activity of daily living. All these have disciplines. You can use VR and augmented reality as platforms and say and things, and connect with specialists. These data can be connected with an occupational therapist, with physiotherapist, with balance and other we can bring in the system that we use is something like it's almost a Dolby surround kind of a thing. So we can very beautifully integrate the vestibular levels of functions also, right? Yes. So the technology, the good thing that we are looking at is how cell phones have become more affordable today, right? Okay, still we have iPhones which are very expensive, but we also have phones that are very thing. So same thing is happening with the VR environment, with the Meta space that is coming up, right? So after Facebook, everybody are going into Meta space, right? So the industry is going to provide a lot of devices that are more affordable. Okay, so the idea of everybody is like now already marriages are happening in the Meta space, right? We are having virtual marriages there, right? So this is going to be reality, and every home is going to have a VR system, right? But how can we as visual optometrists be engaged in, right? That is something that is very interesting for us. And that's where even our research work, you see that, if I can trace your eye movement on while you're watching a movie, can I detect your glaucoma or neuro based on your eye movement kind of a thing? That's the PhD work and our IP on that.
I think of sports vision also, where you can improve
Yeah,
the
huge.
eye movements.
Huge eye movements along with wearables. That's the focus. All these startups or companies are looking at. The HoloSuit company has very well established collaborations with top cricket and other sports engagements. On we can wearable that will give you how your body and your cricket shot is. So coaching will become more tenured. So eventually we are going to be in a fantastic data-driven mixed reality kind of environment. We're going to also have perceptions where you can have a handshake that's going to be more realistic with holographs and things like that. So these are not far reality. The industry is growing very quickly. So by the end of this decade, we should be having fantastic tools.
And I want the students to get inspired from you and dream to be, someone who can bring in some innovation, which is totally change the way the eye care practice is currently operating now. And I wish them also all the best. And I also wish you all the best for bringing in so good vision therapy system into practice.
Pleasure. So it's the main team, my colleagues from Remed have the major credit and things, and we have just facilitators here. Okay, thank you once again.
Sorry, there is one question in the chat box. Is there any ocular effects associated with the use of VR in amblyopia? Because a study shows on choroidal thickness with the use of VR from Gaurav.
So Gaurav, the current literatures that have been supporting and things like that, they have shown that a long-term use of VR I have not updated myself on that paper that you're talking about. Probably if you could share, I would be able to read it better. But the key side effects are on prolonged exposure to VR can lead to the dry eye and myopic simulations. But in our case, that is why we provide only a very systematic, not more than 1 hour exposure. And if you're looking at the effect versus harm, okay, so we are looking at how we can improve an amblyopic child's visual health, and we are seeing that within a 3 months of therapy exposure window, we are able to improve their visual functions, not just visual acuity, but the overall amblyopia outputs are getting improved. So that is the risk-benefit kind of thing I'm looking at.
Ramesh, proceeding to this question, like I have one more question. Being a myopia management specialist, have you ever noticed any, power refractive error change in myopia when you give this sort of virtual reality exercises for an amblyoptic eye?
Yeah, so because again, this comes to the dose that we provide. So we do provide two sessions per day kind of a thing, right? That is almost like an 1 hour exposure to television and things like that. So we are not seeing I do not have the data to show that that is causing a change in the myopic thing. But when I looked at other literatures, when extended use of VR is there, when they are engaged in gaming, using for more than 1 hour, 2 hours, or 3 hours per day, then there is a myopic shift, is what some studies have shown. But from our experience, I have not seen any of our. Our team did not present any of such data. We looked at that, and there was no statistical difference in the refractive
error changes. Oh, that's nice.
One more request for the participants. You can, if you are interested, you can put your contact numbers. So for the further courses, we will be contacting you.
So, yeah. Oh, they are asking us.
No. No. I'm just telling them. So if they are interested in our iFull, so they can put their contacts here, so we can contact them to inform our next courses and other updates.
Yes. So, also, because we are bringing in courses regarding to myopia management and related to psychophysics. We are all, as I said, we are also the next short course would be about how to get a patent for your innovative device. So these things are in pipeline. If you are interested, you can put your contact here so that we'll contact you for our further courses, future courses.
Okay, so thanks once again to all of you. Thank you, Savita. Thank you, Maheshwari.
Yeah, thanks, Ramesh. It was a very nice session. Thanks.
Thank you so much.
Pleasure. So we'll catch up with you all in one of the future sessions. Bye, everybody. Good luck to all.
Thank you for your time.
Bye. Best wishes to you too. Bye.
Bye.
Bye. Thank you, Ramesh.
That's Yemima.
Oh. Thanks, ma'am. Thanks for coming.
Welcome. Thank you so much. A lot of our students have participated here.
So there are 14 students, I think, from Agarwal. They've joined.
Wow.
More than 14, actually.
Okay.
So that was a rough number. Yeah.
So nice.
So I'm seeing a lot of interest. People are posting their numbers.
Yes. Because this is like something different what we have actually done, and future also, ma'am, we are thinking of bringing few courses which are actually not needed for them, but those courses has not been included in the curriculum.
Yeah.
Say for example, getting this patent when it comes to innovation. So that is very important, right?
Yeah.
And also for myopia management. So that is also not available as of now in our curriculum. Maybe in near future, we'll be bringing that in the course. I mean, in our optometric syllabus. I'm also thinking in terms of business communication, all those stuff which are not there in the syllabus, optometric syllabus, but that is actually needed for them.
Yeah. So let us know when you want to bring out the course on patent. We'll be happy to join. And
yeah,
also,
sure.
This currently you are having this VR training.
This is still accessible. If anybody wants to do this course, they can access the course. They have to get enrolled. They can contact either of us, either Maheshwari ma'am or myself. Okay. They can get enrolled, and then the recorded sessions will be there. It will be more self-explanatory. Recorded sessions will be there, but we will be there to guide them. Whatever is, so if after the session, like they can because if it is recorded, they can learn at their own pace also. So if there is any doubt regarding the session, they can contact us and we will be happy to clear their doubts, and we'll also assist them with the project.
What is the course fee?
Right now, the course for the first session we have charged actually less, because we wanted to tell people that this sort of course we are like bringing in. So right now we are planning to charge around 20,000 to 25,000 bucks.
Okay.
Because this VR device itself, like, you can make different. The box might seem simple for you, but the box has a slot wherein you can insert a mobile. The VR box is also, this is the first box in the whole world, we should say, where you can alter the U value.
Okay.
So the distance between the object distance can be varied for any project. So that is the advantage of the VR box. So that sort of box has been made. And the course is exactly, to tell you, it combines, as Ramesh said, he's working with physiotherapists. He's working with for bringing in stroke patient, therapy for stroke patients. He's working with multidisciplinary fields, right? This session has a combination of hardware, software, whatever is needed, to make the virtual reality device. So that sort of course,
Great, great.
and also we want sincere students, because we want the ultimate motto is to bring so many instruments to the field, right?
Yes, yes. So what you're doing is amazing. Great, great. Thank you so much. Yeah, I'm sure that everyone who joins will be benefited.
Thanks, ma'am.
Okay, then. Thank you.
Thank you.
Yeah, thank you for giving this session as a free session. Yeah, so thank you so much. Okay, then.
Thanks, ma'am. Thanks a lot.
See you.
Bye.
Bye-bye.
Bye, everyone.